Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I will present the group 7 for the Aspen plus simulation. So in this Aspen, the required is to respond to the experimental and simulation outcome of separation process experiment. And the terms that been given is your group will be assessed on the presentation of the simulation process for a given unit operation. The condition of the process are given in the problem. So the problem statement is a feed mixture consists of 14% ethanol solution is fed to a distillation column at a temperature of 85 degrees Celsius and pressure at 3 bar. The flow rate of the feed stream is 100 kmol per hour. The flow rate of the distillate is 30 kmol per hour and the reflux ratio is 2. The column consists of 30 bubble cap trays. The feed tray is located on the number 10 tray. The pressure on tray number 1 is found to be 1.01 bar. The mole fraction of the ethanol at the distillate should contain at least 0.83 and at the bottom stream not more than 0.22. Based on this condition, simulate the process of for this distillation column, and you may improve the mole fraction at the distillate and bottom stream by increasing the reflux ratio to 4. So our group member for this experiment is Muhammad Fawaz bin Muhammad Saroji, Muhammad Amal Akil bin Muhammad Azian, and me, Muhammad Izzul Wafiq bin Muhammad Fazlin. So the objective that we want for this Aspen simulation is to determine the mole fraction of ethanol and the water at distillate stream and the bottom stream. Second one is to determine the effect of reflux ratio on the purity of ethanol produced at the distillate stream and the theoretical number of stages required for the process. So as our group do the Aspen simulation, we get the specification of the distillation column, which is DC is red fraction 1. Number of stream is feed, distillate, and bottom. The type of column is equilibrium column. As mentioned in problem statement, the number of stages is 30. Type of condenser is total condenser, and the type of boiler is Catton. So for the first one, we run the simulation with the reflux ratio 2, which we get in distillation stream. For the molar flow rate is 24.2877. Meanwhile, for the bottom stream is 15.7123. And for the mole fraction of ethanol is 0.80959 and 0.224462. This is from our experiment, and we to get the as mentioned at the problem statement, you can use the 4 as a reflux ratio. We put the input in the next and the second run, which cause the molar flow rate at distill and bottom to change, which for molar flow rate is 35.0322, and for the bottom stream is 14.9668. Meanwhile, for the mole fraction of ethanol is 0.83444, and for the bottom stream is 0.213811. So the question is, discuss the relationship between the reflux ratio, purity of ethanol at distillate, and the theoretical number of stages required for the process. So For the first question is when the reflux ratio increase, the purity of ethanol also increase because the result of ethanol mole fraction in distillation is 0.80959 when reflux ratio is 2, and the result of ethanol mole fraction at reflux ratio 4 is 0.834441. And for the justify your answer, we screenshot the Aspen simulation data, which at the mole flow and the mole flow rate, we can see the data here. This is for the reflux ratio 2, 0.805959 and 0.22446. Yes, and this is for the mole fraction with for the first run, which we can see the mole fraction for the vapor is higher than the liquid. And this is for the second run, which we use the reflux ratio 2. We can see here the data is changed to 0.834441 and 0.213811. So this is for the second run. So the graph for the reflux ratio, which is the green line is the for the vapor and the blue line is for the liquid. And yeah, so that's it from me for the Aspen simulation. Thank you.